This is PreCalc 11, Chapter 1.4. This time we're going to look at geometric series, and it's similar to arithmetic series because it's a sum of a sequence. And where it differs is that we can find the sum of some infinite sequences. Recall that for arithmetic series, there is no sum for infinite sequences because it's just infinity. Okay, here's an example. Find S6 using t of n as 8 times 1/2 to the power of n minus 1. So if we just write it out, 8 times 1/2 to the power of 0, that's 8. 8 times 1/2 to the power of 1, that's 4. And so on. We get 8 plus 4 plus 2 plus 1 plus 1/2 plus 1/4. So S6 equals 8 plus 4 plus 2 plus 1 plus 1/2 plus 1/4. You'll want to note that R is equal to 1/2. And this is 15 3/4. Or we can use an improper fraction and say that's 63/4. And recall that to change to an improper fraction, we take the whole part, multiply it by the denominator, and add it to the numerator to get the new numerator. If we have a longer series, we're going to want a formula. So let's try to develop a formula. So we have S5 equal to 8 plus 4 plus 2 plus 1 plus 1/2. Remember, this is 5, so we don't have the quarter. Now, if we try to rearrange and add it up like we did for arithmetic, it's not going to help. Since geometric series involves multiplying, let's multiply by r. So if we're multiplying this by 1/2, we get 4. This by 1/2, we get 2, and so on. And we end up with this times 1/2, that's 1/4. So what we're going to do is we're going to subtract these two. So we get S5 minus R S5 and 8. 4 minus 4, that cancels out. 2 minus 2, that cancels out. So all these are going to cancel out except for this quarter. So we have minus 1/4. Now what we can do is factor out an S5, and we're left with 1 minus R. 8 minus 1/4, so 8 times 4 is 32 minus 1, that's 31. Now we can substitute R, which is 1/2. So we have 1/2 S5 equals 31/4. Now we need to divide both sides by 1/2. That's the same as multiplying by 2. So 31 times 2 is 62. And if we look up here, this is S6, so we need to just add 1/4. Adding 1/4 to 62/4 gives us 63/4. So that shows that our formula here works. So we have Sn equals this value equals, so we did this minus this, gives us the first term minus the last term, plus 1. So T1 minus Tn plus 1. Remember, T6 is 1/4. So this is 1/4 Tn plus 1. We're doing S5 here. And we're dividing this by 1 minus R. Now we can substitute the formula for this. T1 minus T1 times R to the n, and that's 1 minus R. Now what we'd like to do is factor out a T1 here. T1 times 1 minus R to the n. So this is Sn, and we have a restriction here, R does not equal 1. Because if we have 1, 1 minus 1 is 0, so we can't divide by 0. And this formula is convenient to use if r is less than 1. From here, we can get another formula. Sn is equal to T1 times r to the n minus 1 all over r minus 1. And we'd like to use this if r is greater than 1. What this does is it prevents us from using negative numbers. And how do we get this? Well, we get this by factoring out a negative 1 from here and here. And then we just cancel out the negative 1s. And we're factoring it from the numerator and denominator. So here's an easy application. We have the geometric series 1 plus 1.1 plus 1.21 plus 1.331 and so on. And we're asked to determine S11. So R equals 1.1 divided by 1. Well, that's just 1.1. And if you want to verify this, you take 1.21 divided by 1.1, and that should give you 1.1 as well. T1 equals, well, it's just 1. So Sn equals T1. Again, we write out the formula until we get used to what the formula is. So S11 equals 1 times 1.1 to the power of 11 minus 1 all over 1.1 minus 1. And if you plug that in on your calculator, you get 18.53. And of course, we're going to be asked to do backwards problems. So we're given different info and we need to solve for a different variable. We're not asked to solve for the sum. Okay, the sum of the first 6 terms of a geometric series is 2548 and the common ratio is 3. Find the first term of this series. Okay, so just write out your formula. Sn equals T1 r to the n minus 1 all over r minus 1. We can substitute S6. We know it's S6 because we have 6 terms. And that we're told that the sum is 2548. We don't know what the first term is. We do know what the ratio is. 3 and n is 6. And 3 minus 1. So 2548 equals 3 to the power 6 minus 1 gives us 728. And T1 stays, and we're dividing by 3 minus 1, that's 2. So we need to multiply this side by 2 divided by 728. So T1 equals, and that equals 7. So our first term is 7. Now for harder problems, we're going to have to figure out what the term number is. And you can just multiply on your calculator until you get an answer, or you can use logarithms. Logarithms are part of PreCalc 12. But you're just going to be using the simple version of the logarithms. It's not too hard. If you have trouble, please ask me for help. Okay, we need to calculate the sum of a geometric series. 5 plus 5 over 2 plus 5 over 4, and so on. So Tn equals, we know the first term is 5, and the ratio is a half, and n minus 1. We're going back to chapter 1.3, and we need to figure out the term number. So this term is 5 over 256, and we have 5 times 1/2 n minus 1. Divide both sides by 5, you get 1 over 256, 1/2 to the n minus 1. Logarithms are just the opposite function of exponentials. So now we take log 1 over 256 equals log 1/2 n minus 1. Now the property of logarithms that we need to use is that the exponent is the opposite, so we can just bring it out front. So now we solve for n minus 1. We need to divide both sides by log 1/2. And now we just add 1 to this side. And you can just plug this in on your calculator. And we get 9. And if you don't know how to use your calculator, let's just bring this up. So we have log 1 divided by 256 divided by log 1 divided by 2 plus 1. And we get 9. So we're only halfway there. S9 equals 5 times 1 minus r to the 9 all over 1 minus r. And this time we're using the other formula because r is less than 1. And we want to just keep things positive. So 5 times 1 minus 1/2 to the power of 9 over 1 minus 1/2. And again, we want to keep things as fractions. We don't want to use decimals because we want an exact value. And 1 minus 1 over 512, that is 511 over 512. And dividing by 1/2 is the same as multiplying by 2, so let's bring that up top. And we get 2555 over 256. And just in case you want to know the rules, the log law is log a to the power of b is the same as b times log a. And again, logs are the inverses of exponentials, and that's why we can pull the exponent out front. And that completes this lesson.